One way you'll see a lot of indirect proof is something called number theory. Because for an indirect proof, sometimes it's just easier to do it with number theory. Here I'd set up part of it for you, but I want you to finish it. So we're supposed to write an indirect proof that if, notice the if part is my given, so that if x squared is an odd integer, notice we're given x squared is an odd integer, then I want to prove x is an odd integer. So I want to prove x is an odd integer. Now I think, what's the opposite of odd? Well, I'm going to assume x is an even integer. Now the number proof part, I got to do something to show it's even. So what I'm going to do is I'm going to let x equals 2k, where k is some integer. No matter what I do, if I multiply by 2, I'm going to get an even number, aren't I? So I assume x equals 2k. I probably should have put that in my first part. So x equal 2k. Now if I square both parts, notice I get x squared is 2k squared, because I'm taking that even number and I'm squaring it. If I do 2k squared, I'll get 4k squared, because 2 squared is 4. I can factor 4k, or 4, to 2 times 2. So then I got 2 times 2 squared, 2k squared. Uh-oh, do you see the contradiction? The contradiction says, our hypothesis said that x squared was even. But, I'm sorry, we said it was odd. But when you multiply by 2, that makes x squared even. This makes x squared even because we're multiplying by 2. A contradiction. Our assumption is false. And we're going to say x is an odd integer. Maybe I should have put a contradiction. X squared is an odd integer. Although I don't think you really needed to, I'll put that in here to make it more clear. There's your contradiction, because x squared, which is 2k squared, is now even. And there's your problem. Okay, let's take a look at another one here. On this one, we're not going to do the whole proof. I just want you to do the assumption. The assumption, remember, is we're going to assume the opposite of what we're trying to prove. So if xy is an even integer, that's our given, isn't it? Then either x or y is an even integer. So I want to assume the opposite of that. What's the opposite of being even? It's being odd. So we're going to say either x or y is odd. Then I would do my proof from that step in the normal way, which you've done before, until you come to a contradiction. But I just really want you to understand the assuming the opposite of what you want to prove when you do an indirect proof.